Hi, uh, today we are going to take up some more problems on overhanging beams. Uh, we have a problem over here where we have both point loads as well as UDL, and we have a support which is support on this is a support point support, and here we have support on rollers. Now a beam of 8.5 meter long rests on the support 5 meters apart, and the beam carries a load as shown in the figure. We are supposed to draw the SFD and BMD. Now first of all, we will convert this into point load. Now here we have the load is from the top, that is 40 kilonewton. Now here we have suppose RA. Now this was given as 50 kilonewton per meter, and this is stretches for 5 meters. So now if you convert it to point load, this becomes 250 kilonewton, and it is acting at 2.5 meters. 2.5 meters from here. Then we have RB. Then for another 2 meters, then we have here another load of 60 kilonewton at D. Now suppose we do summation of MA is equal to 0 minus 40 multiplied by 1.5 plus 250 multiplied by 2.5 minus RB multiplied by 5 plus 60 multiplied by 7 is equal to 0. So 5 RB is equal to 250 multiplied by 2.5 plus 60 multiplied by 7 minus 40 multiplied by 1.5, which comes to 985. So RB is equal to 197 kilonewton, which is this direction. Now summation of Fy is equal to 0 minus 40 plus RA will give you minus 250 plus 197 minus 60. This is equal to 0. So from here we can calculate RA is equal to 153 kilonewton, which is also acting upwards. Now we will do the SF calculation. SF CL, left hand side is equal to 0. SF CR is equal to minus 40 kilonewton. SF AL is equal to minus 40 kilonewton. SF A right hand side, that is equal to minus 40 plus 153, which is equal to 113 kilonewton. Then SF BL, 113 already we have got, minus 250, which is equal to minus 137 kilonewton. SF BR is equal to minus 137 plus 197, which is equal to 60 kilonewton. Now SF DL is equal to 60 kilonewton. SF dr is equal to 60 minus 60, which is equal to 0. Now we will do the BM calculations. BM at C is equal to 0. BM at A is equal to minus 40 multiplied by 1.5, which is equal to 60 minus 60 kilonewton meter. Now BM at B is equal to minus 40 into 6.5 plus 153 into 5, which comes to we'll have this also, minus 250 into 2.5. So BM at B, it comes to minus 120 kilonewton meter. BM at D is equal to 0. Now we will calculate the point of contraflexion for SF. Point of contraflexion for SF. We'll take up the method that we had taken up in the last class. Here we have 113. Suppose this is x, this is 5 minus x, and this is 137, suppose. So by similarity of triangle, we have 113 by x is equal to 137 by 5 minus x. So if we calculate x from here, x is equal to 2.26 meters. Okay. Now we will find out BM maximum also. BM maximum is, first of all, BM equation we will find out. BM equation, suppose for max only we find out, that is minus 40 x plus 1.5. Why I am taking x? Suppose we are taking x here somewhere, this distance is suppose x plus 1.5 I am taking, plus 153 multiplied by x minus 50 into x, which is acting at x square by 2. So this gives us an equation. If we solve this, it is giving us, this is equal to 0. So we have 25 x square minus 113 x plus 60 is equal to 0. So from this x comes out to be 2.26 meters. This is not equal to 0. We are not calculating. This is the BM. So suppose we put now x from here we have got. From this only we will put x is equal to 2.26. So if we put BM 25 into 2.26 square minus 113 into 2.26 plus 60, we are supposed to find out BM maximum. So that is coming to 67.69 kilonewton meter. Now here we are supposed to find out the point of contraflexure of BM also. So that we are supposed to calculate. So for that we are supposed to put BM is equal to 0. Now, so for point of contraflexure of BM, we have 113x minus 60 minus 25x square is equal to 0. So 25x square minus 113x plus 60 is equal to 0. From this, what we get is x is equal to 3.9055. So which can be approximately written as 3.91 meters. So therefore, x, this is one of the this thing, because two value of x we will get. Another x is 0.615, which can be written as approximately 0.62 meters. So distance, therefore the distance from C is equal to this plus 1.5. So it will be equal to 1.5 plus 0.62, which is equal to 2.12 meter, and another is 1.5 plus this, which is equal to 5.41 meters. These 2 points also we'll have to keep in mind. Now we will draw the final SFD and BMD with these, keeping these points in mind. Now here we will drop this. We have drawn this. Now here we have negative 40. Here we have negative 40, that is 40 kilonewton. Here we have 113 kilonewton. This is negative, this is positive, and this is 2.26. This is 137 kilonewton. This is again negative. Here till here we have 60 kilonewton. This will be positive. This is our SFD. Correspondingly, we have at the point of contraflexure we will have the maximum. So this will come down. This distance is 2.12, and this distance, this distance is 2.12. Another point of contraflexure, that is this distance, is 5.41 meter. This is 60 kilonewton, meter. This is negative, and this is the highest point where SF is 0, so 67.69 kilonewton. This is positive part, and this is negative. The lowest point is 120 kilonewton, and here it is 0. So this is our BMD. Thank you so much, and please subscribe to my channel and ring the bell so that I can come back to you with my next lectures. You will be informed about my next lectures. Thank you.